Good afternoon from Helsinki. My name is Alessandro Chiariello. I'm the EUMeTrain project manager, and I will introduce you this weather briefing, which is coordinated by the Finnish Meteorological Institute. So today, meteorologist Antti Kokko will be giving you an overview of the weather, of today's weather 12 UTC. Is now sitting nearby, and then he will be followed up by Ivan Chonevsky from ECMWF, who will focus on a longer time range. And last but not least, it would be nice that you practice what you've learned in the slide before, and you tell other people where you're from. What is your main duty at work? Are you a forecaster, or maybe more in training, manager position, or researcher, or whatever other? Sometimes people have indicated some IT stuff. So since that most of the people are from the forecasting, which is nice. And yes, maybe I'm here nowadays. I'm managing. Okay, so now I will give the floor to the guy just next to me, Antti Kokko. He will talk about the weather of today. Okay, thank you very much. Enjoy.
Okay, hello, good afternoon. This is Antti Kokko speaking, FMI forecasting office. I'm on duty now. Started at 10 o'clock local time, so 4 hours ago, and I had a good time to get myself into the weather. And I'd like to take an outlook to the synoptic weather situation in Europe in general, and then look at more specifically some interesting points we are going to find. But first, let's check the JET 300, so the geopotential height in 300, and also jet streams at 300 hectopascals. This is the European Center model for at this very timestamp. So as we can see, here is quite deep, and also center of upper low can be seen in 300. There's a ridge of high or upper high in reaching Scandinavia from Central Europe, and there is also another low in region of Italy. With color you can see this jet streams, and there are small numbers also. I'm not sure if you can see those, but there is quite a strong one, quite strong jet stream over the northern Atlantic, which is related to this low. Here is another jet stream, and also this low over Italy is strong enough to make not that strong one, but if you compare to this one over the northern Atlantic. But anyway, in here is also jet stream. And then a nice colorful image, also this 12 UTC today, geopotential height of 500 and temperature of 850. The temperature is illustrated with colors, and these thick lines, thick isobars or isohypes are the JET 500, and then the thinner lines are the surface pressure. We now remember still that we had a really strong jet stream around this region where the gradient is the strongest, and as we can see, there is gradient in temperature. As we know, these two are related to each other, and here we can see it quite clearly. Also we can see that within this deep areas of low there is cold air mass, and then Northern Africa, Mediterranean region, warmer air mass on average. Okay, we proceed to the next one. I decided to show you also this surface pressure itself, and also maximum gusts of the European center model. Here we have this really deep surface low, center of low. It reaches down to, is it 958 or something. Excuse me. And this red region here is area of gusts with 40 meters per second, so really strong ones. Luckily they are now on the sea area, over the sea, not over the land. And here over Italy we had this upper low. It can't be actually seen that well in the surface pressure field. There is some weak surface low also. But in here over the Central Eastern Europe there is this strong high pressure. Okay. And then the satellite image, I'm not sure if you're familiar with this combination. This is one of combinations I like to use myself, infrared combination mostly, but it also reaches the visibility channels, so it looks a bit different during different times of the day. But still with white colors you can see the high thick clouds, and then actually you could say something else, this greenish or turquoise, or somewhere in here the reddish are the low clouds. Here we can see quite nicely this really strong center of flow, and well, the sea in here is sea water is relatively warm still, and when we get this cold air mass above the sea there is quite unstable situation, and it generates really nice beautiful convective cloud cells, so to say. Around this here in the Italy region we had this low somehow seen in the surface fields and better in the upper troposphere, but here is also some frontal activity related to that one. Okay, then I'm showing to use maybe something more special stuff already. Here in FMI we took this European center's total precipitable water kilograms per cubic meter. So this is, you think, is same way as with the Dobson unit. So it's the whole column of water. Whole column of air, and the precipitate in that column. And here I have also this Jet 500. And with colors you can see this water amount. You can think it as absolute humidity. And in here we have quite nice values already, really high values, which illustrate the potentiality of severe rainfall, especially these purple areas. And actually with these thresholds we use in FMI, this is the colors especially for our use, summertime use, when we forecast severe precipitation. This applies quite nicely as well to, or at least somehow to Southern Europe. If we check Meteoalarm this morning, we can see that in Italy and Spain and Portugal as well, there is a warning of severe rainfall. Now, some reason Finland is blank today. We're trying to fix it. Okay, I took a model sounding from central Italy. This time the European Center model sounding. I'd like to ask you now that can you tell me where, in which level, which height is the tropopause in this sounding? You can mark it with your this tool, for instance. Yes, exactly, that's the point. And well, as you can see, it's quite on a low level. If you think, well, it's end of October anyway, but quite low level it is. And what's the reason for that? Well, if we take a look the Airmass satellite image this morning 06 UTC, we can see that well, in this product the red colors especially can be seen in here. It illustrates Airmass descending from stratosphere to troposphere, so really cold Airmass. You can see it somehow also in this central Italy region. And as we remember, we had low area flow in here, not a very strong one, but in the northern Atlantic we had really strong low, and also in here Russia area of low. So the thing is that a cooler air takes less space than warmer one, so in area of low pressure constant pressure levels are coming down with height when there's area flow. Now the coming slide I'm going to show you a sounding near Barcelona region in Spain, about in here. And can you mark again tropopause in this sounding, please? Yes, there is on a much higher level, around 150 or 200 hectopascals. As if I go back with this sounding of central Italy, there it was maybe, well, around 300 hectopascals. So there really is a difference, and that's because there is this upper low or area flow in Italy. That was the very thing I wanted to mention, and I'm happy to see that you are quite familiar with this. Okay, it's 15 past 12 now. I guess I'm giving the shift to talk to Ivan. Thank you.
Okay, good afternoon from the European Center for Medium Range Weather Forecasts. So now I'm going to focus on long range weather forecasts. These plots show our recent monthly weather forecast, week 2. The upper left plot shows the precipitation anomaly, and the bottom left 2-meter temperature. These are standard plots that can be seen on our web. So they represent anomalies around the globe. we can see few areas of significant anomalies in terms of temperature and precipitation. But what these anomalies cannot show us, or we don't know from these plots, how extreme actually these anomalies are. And to address this, we are testing here some new products based on the Extreme Forecast Index. And on this slide, you can see on the right-hand side of the slide the corresponding Extreme Forecast Index forecasts. So this is some test product we are testing now, and we'd like to see whether it makes sense to produce such kind of forecasts. Can we actually pick up some extremes in the long range? And that's why we don't know at the moment. We are producing now these forecasts, and we are looking at to figure out how useful they could be. But I'm going to show you some, to give you some hint, what can we expect from these forecasts. So here, this is again week 2, and week 3, we see much less anomalies around the globe, especially for precipitation. These plots, the anomalies in TFI, they resemble quite well, but also we can see some differences. For example, on the around Siberia, we can see just a moment to pick up the two. So over Siberia, we can see this anomaly. Yes, it's red, and I'll use the star. So this, but actually we can't see so well in the EFI plots. I'll come back later on this. Let's focus now on Europe. So for Europe, week 2, this is the forecast for the next week. We can see that most of the continent, the weather will be dry. This is due to a high pressure system that will persist over Europe next week. But the EFI plot, again, I want to point out, this shows us where the forecast, where we can expect extremes in terms here, in terms of precipitation and temperature. This is week 3 forecast, much less signal as we can expect, but at the same time, I want to point out this area of over Scandinavia, where we see positive temperature anomalies, and we can't see much on the EFI plots. I'm going to show you now some cumulative distribution functions, some distributions of the ensemble and the climate, and to figure out what's going on, why something appears on one of the plots and not on the other. So this is the temperature anomaly forecast for next week. I want to show you two CDFs over 2 different locations. One of them is over Scandinavia, so where we see quite significant positive temperature anomalies. As we can see from the model climate, the model climate starts from -20, and the maximum is just above 0, +3 degrees. So it covers, supposed to cover the whole range of values in the past 20 years for this time of the year. And this is the forecast in red, which you can see. So actually the average anomalies are around 4 degrees, so they are significant. The this forecast, the range of the forecast is much narrower, so it starts from -5 degrees and reaches almost the maximum values of the model climate. So we have really forecast distribution which shows significantly warm conditions over Sweden in that point that I show. And another point that I want to show, another location, this is over Bulgaria's point, typically representing the Danube Plain. So in this CDF, we can see, again, the model climate starts from -3 degrees, goes up to 17 degrees as an extreme, while we now can see that the forecast actually is quite cold in red. So the temperature anomalies are quite significant, but on the other hand, the fact that we don't see these black contours here, where the EFI is, negative EFI, means that we don't expect extremes in this location in terms of weekly mean temperature. And indeed, the CDF shows that it's quite vertical, by the way. It's quite confident of cold weather, and it doesn't show any particular extreme values of temperature, extremely low values of temperature. That's what we can see here from the EFI plot directly, and we can't see this from the anomalies, just looking at the anomalies. So that's what the EFI gives us a hint how extreme these anomalies are. Now about the precipitation for next week, again I'd like to point out these two CDFs. One is over Turkey, and as we can see from the anomaly plot, there is no signal, it's blank. And I've seen quite a lot of people, some common misinterpretation of this is that, okay, they say, okay, it's blank, so it will be average. But this is wrong, and the CDF actually shows this. We can see that CDF follows the model climate. So actually what we can see, what we can say, we don't know. We don't know what exactly is going to happen there in terms of precipitation. The forecast gives us quite wide range following the model climate. So there is no predictable signal rather than saying, rather than seeing the model climate. So nothing predictable more than the model climate. But in some other location, for example, the southeast Spain, we do see some anomalies, even some positive values of SOT. It's -1, and this is because these tails of the distribution, of the forecast distribution in red, is quite far from the model climate distribution. So in this location, pointed out here, we can expect some extreme precipitation. This is likely, and at least 10% of the members, just looking at this plot, we can say that just at least 10% of the members predict precipitation more than the 99th percentile of the model climate. So this gives us quite useful information on top of the anomalies. Just looking at the anomalies, we can't see this additional information that we can see from the EFI plots. This is week 3 forecast for temperature. We see here in this area of Scandinavia some anomalies in terms of temperature, but we don't see much in the EFI forecast. And this CDF here actually shows why. So we have the model climate in black, and the temperature is slightly shifted to the warm side, but it's still quite close to the model climate. So it doesn't show us significant anomaly. So this anomaly is not significant in the forecast, and we don't see much extreme values. And again, to stress that when we see blank areas like here in Russia, we actually see that we can't say actually what's going to happen there, because the forecast is so uncertain that all solutions are possible. So, but we still can see from this plot here that we can't expect too low temperatures in this location. And to figure out what's going on here over Siberia, where we do see some significant anomalies, actually it's quite big, the range of the climate from -35 to -3 degrees, and the forecast is again quite wide range, covers quite wide range from -20 degrees to about -4 degrees. So that's why although the anomalies are about 4 degrees, we can't see much from the EFI plot, because the EFI takes into account the whole distribution, and it tells us that the forecast also covers quite wide range from the forecast. But we can see here, at least from the EFI plot, which shows us SOT as well, that we can't expect extremely high temperatures in that location. And now for the precipitation over Europe, just to show you that when we see blank plot here on this map, on the anomaly map, the EFI just displaying the CDS, we can easily figure out that the forecast is quite uncertain and covers quite wide range of possible solutions, but no extreme values in terms of precipitation, and this is around Paris. So these are some discussion that I showed you, the last products we are testing here at ECMWF, and any feedback on these are very welcome, and this is my email. You can email me when you have what to discuss with me, so I'm happy to hear from you. Thank you very much.